For the divergence theorem, usually you're going to be working from the left-hand side to the right-hand side, because usually triple integrals are more convenient to compute than the surface integral. So what you have to do is just check that your surface works for the divergence theorem in order to compute and use the divergence theorem. So we're just going to ask ourselves what surface works for the divergence theorem. So we're just going to look at the definition here. Let E be a simple solid region and let S be the boundary surface of E. Well, that means a couple things. One of the main things you want to make sure you check is that S must be closed. And S, we'll just say shorthand, S must be well behaved. And what that really means is that S can't cross over itself, that volume is also connected and in one piece. And the last thing we're going to look at here is let F be a vector field whose component functions have continuous partial derivatives on the open region that contains E. So really, this just means, again, F, that vector field, must be well behaved as well. So again, one of the main things you're going to want to do is check that S is closed. For this course and the book and everything, usually you're not going to have a problem with these things. But I thought I'd mention that that these are the things you want to check about the surface and that that vector field F before you use the divergence theorem. And that you're usually going to go from that left-hand side to the right-hand side because triple integrals are more convenient to compute, although you could go from the right-hand side to the left-hand side as well.